IGCSE Cambridge O-Level Computer Science, Paper 2 for session October-November 2025. Question 1. 4 descriptions of structured query language SQL keywords and 5 SQL keywords are given. Draw one line from each description to its matching keyword. Not all SQL keywords will be used. So firstly, identifies the database table. That is the keyword from. Sets the condition, that is where. Sorts the results, so for sorting we will order by, and returns the number of records, that will be count. All right, cannot help you much with those, just kind of have to memorize the SQL keywords and their description. Okay, question 2. Identify 3 different types of test data that can be used to test a program. So we have firstly normal test data, right? Normal test data. We have abnormal, right? Right, which is basically false. We have extreme and boundary on the bounds. Pretty simple. So tick one box to identify the operator that returns the quotient of a calculation with the fractional part discarded. So this is normal division, right? This is power, okay? And a modulus returns the remainder. So by the process of elimination, we only have div. That's of course if you forgot what div does, but you're supposed to remember in the exam. Question 4, part A. A restaurant offers a fixed price menu. A meal for an adult costs $9.99, and a meal for a child costs $6.99. If there are 6 or more people at the table, a 15% discount is applied to the total cost of the order. Write an algorithm in pseudocode to input the number of adults and the number of children at a table. So let's take this first. So to input anything, we need to first prompt the user by outputting the message. So output please, right, enter the number of adults, right, and then input adult, right, let's name the variable adult, and then we're gonna output again, prompting the user to please enter the number of children, right, and then we're gonna input a variable called children, which contains the number of children, right? So then we're gonna calculate using a new variable. So let's call it total, right, and set it equal to the formula, right? So a 15% discount is applied to the total cost of the order if there are 6 or more people, right? So firstly we need to calculate the total, which is basically $10 for the adult and $7 for children. So adult multiplied by the cost of an adult, which is 9.99, plus children, right? Children multiplied by 6.99, right? That is the total amount of dollars to pay. And then output the final cost of the order. But before that, we need to calculate the total cost. We already did that with the discount if this applies. So this is the total. Now we need to basically find out if the discount applies. That is if there are 6 or more people. So if there are 6 or more people, we're gonna edit the total, right? If there are not 6 or more people, then we're not going to edit the total. How are we gonna do that? So if adult plus children is basically greater than or equal to 6. Greater than or equal to 6. Okay. Then we will basically apply a 15% discount, which we will calculate by doing total is equal to total minus total multiplied by 15 divided by 100, which is the multiplier. This is normal math, 0.15 multiplied by the total, that's 15%, and we're gonna take 15% from the previous total and store that in the variable total. Now we're going to end if. So after this if statement, our total is correct, right? If this statement does not apply, then it's the original total. If it does apply, then it's discounted by 15%. So in the end, we just need to output the final cost of the order. So output the total is total. That is it. This is how we're going to do it. Just prompt input, and then calculate the total. Check using an if statement if the discount applies, and if it does, we're going to calculate the new total, and then we're going to output that total. Very simple stuff. All right. So for part B, the final cost of the order after the discount may have more than 2 decimal places. Okay. Write a pseudocode statement to set the final cost of the order to 2 decimal places. You do not need to rewrite the whole algorithm. Okay. So basically, we have a very useful statement, which is round, right? Round basically rounds any number. But if we just round, that won't do nothing. We have to put in parameters. So we're gonna round the total, right? Total to 2 decimal places. And that will still do nothing, right? Because we have to store that new rounded value in a variable, and let's call that total. So total is equal to round of total and 2. And then for part C, the restaurant offers a discount on a meal if the person ordering is either a student or is 65 years or older. The discount x is equal to 1 can only be given if the amount of the order is $20 or over. Write the logic expression for this problem. Okay, so basically, if the person ordering is either a student, right? So a student means not A. This is A. A, when it's 1, it's not a student. When it's not A, it's 0 and it's a student, right? So not A, right? And in terms of B, he must be, no, it's or, right? It's or 65 years or older. So or B, because when B is equal to 1, it's 65 years or older, right? We don't have to put any not, because we're meaning this, not this, right? Rule C, the discount can only be given if the amount of the order is $20. That means that we have to use an and on all of this, right? And $20 or over, so this one, that means C. So the final answer will be not A or B, right? And C. Okay, so part II, draw a logic circuit for this logic expression. Each logic gate must have a maximum of 2 inputs. Do not simplify this logic expression. Okay, so let's take this step by step. Firstly, we have a not on the A. Let's just get rid of that, right? Okay, now we're done. Okay, then we're gonna have to OR it with the B, right? So let's draw an OR gate. Okay, we're done with the OR gate, and then we're gonna have to AND the output with C. So let's get C from here, right? This is the final answer. So we connect it to X and we're done. It's very simple. 1 mark, second mark, third mark. 3 out of 3. Very simple. No need to be confused. Okay, part D. Draw the NAND logic gate symbol and complete the truth table for it. Okay, so the NAND is basically an AND, right? An AND with a circle. And this circle represents a NOT. So the truth table for an AND is 0, 0, 0, 1, right? 0, 0, 0, 1. NAND is just the opposite of it because it's not. So not 0 is 1, not 0 is 1, not 0 is 1, not 1 is 0. We're done. This is the NAND, right? Opposite of the AND.